Now, I think we stop from here, right? For the probability and statistics.
Where is it?
Is it, yes, 2 point, this one I think we did. And for the,
Yeah, we completed the 2 point, sorry, 2B as well.
okay, 2B, that means for
Yeah,
these ones. So for the
after
last
that.
four ones. Okay, okay, after that. So here for this Explore 2.3, they have given us six card numbers. That means 1, 2, 3, and 1, 2, 3, 4, 5, and 6 are placed in a bag as shown. So 15 different pairs of cards can be selected without replacement from the bag. Anyway, when it comes to what we call the taking cards, we have like two methods. One is with replacement, the other one is without replacement. So the meaning of these ones with replacement means once we take out, we'll put that card, that one, to the bag or box again and uh, do the picking thing again and again repeatedly. That is for the uh, we are putting it back to our box or something, and then only we'll do that. So that's what
Okay.
we call the with replacement. What about the without replacement? So without replacement means we'll take it from that මොකක් හරි තියෙන මල්ලකින් we'll take it and keep it aside and then do the second choice. That's the without replacement. With replacement and the without replacement. So here we have six cards numbered. 1, 2, 3, 4, 5, and 6 are placed in a bag as shown, and 15 different pairs of cards can be selected without replacement from the bag. Three of these pairs are among those ones. Three of these pairs are 2, 3, 6, 4, and 5, 1. How it happens? So, anyway, for the first choice, there we can have either 1, either 2, 3, 4, 5, and 6. Let's assume we just with replacement. No. Okay, without replacement means we are not putting it back. Then for the second choice, if we draw it for the second choice, 1, 2, 3, 4, 1, 2, 3, 4, 5. We have only 5. So as for the first choice, we take one out. We have 2, 3, 4, 5, 6. If we take these two out, then we have again another five choices for the second choice. That is 1, 3, 4, 5, 6. Likewise. Now what they are saying, this is kind of a tree diagram. So now what they are saying, make a list of all 15 unordered pairs, and find the mean of each. We will denote these mean values by x2. So here they have given 15 different pairs now. So 15
Yeah.
different, so we can write the combinations here for the first one, 1, 2. This is 1, 3. This is 1, 4. This is 1, 5. This is 1, 6. And again it would be 2, 3. 2, 3. Then 2, 4. 2, 5. Likewise, but 2, 1 won't be there because the combination is already there. අපිට
Yes.
අර ඉස්සල්ලාවේ මොකද්ද පස්සේ ආවේ මොකද්ද කියලා වැඩක් නැහැ. We are just checking with the combination. එතකොට 1, 2 is already there. ඒ වගේ they ask us to write all the 15 different unordered pairs and find the mean of each. Find the mean means here 1 plus 2, that is 3. 3 over 2, that is 1.5. 1 plus 3, that is 4. 4 divided by 2, that is 2. 2.5. Likewise, they ask us to calculate the mean of these outputs. So then what we can do, once we calculate that one, make a list of all 15 unordered pairs and find the mean of each. We will denote these mean values by x2. Then they are saying, choose a suitable method to represent the values of x2 and their frequencies. Find the x2. Okay. Can you do up until here? I mean, draw this tree diagram and find out what are the 15 different pairs. 15 different pairs. There should not be any duplicated ones. 15 different pairs, unordered ones here. And can you list down it? First do that part
Okay.
from here to here.
Which is 1 1 a pair here?
No, 1 1 can't be without replacement. 1 1
Ah,
happens if only the with replacement. Once we take one out, then again we should put it back and then pick it.
okay.
හැබැයි මෙතන තියෙන්නේ they are saying without replacement. Without replacement means if we take it out, then we have to keep aside and do that thing from the rest.
Okay.
So actually it would be for the if I take these ones, what we call the paint.
I got the 15 pairs, teacher.
Okay, so here එතකොට වෙන්න ඕනේ what are those ones? Let me 1 2 1 3 1 4 likewise, then 2 3 2 4 2 5 2 6, then again 3 4
Oh,
3 4 3 5 3 6 likewise there are like 15. Now what they
yeah.
are saying, then we need to calculate the mean as well. Mean also you calculated, right?
No, I did not.
Okay, so for the means, what will happen? These are, if we think about these ones as samples, 1, 2, 1, 3, 1, 4, 1, 5 separate ones, then we need to calculate the respected mean values aside. Total 1 plus 2, that is 3, 3 divided by 2, 1.5. 1 plus 3, 4, 4 divided by 2, that is again 2. 1 plus 4, that is 5. 5 divided by 2, that is 2.5. Likewise, we can calculate the mean of these one.
Okay, I calculated the means.
Okay, then the means also calculated. Now what will happen? Choose a suitable method to represent the values of x2. X2 means all these mean values. So choose a suitable method to represent the values of x2 and their frequencies. Find x2 bar, the mean of the values of x2. Is it clear for you what they ask?
Yes, yes.
First, among those ones, choose a suitable method to represent the values of x2 because
So like a table, right?
yes, we were talking about the means mod and these ones in here. Itagoda
Yeah,
among those, all these x2 values, what would be the mean kira tamai yahan? You can calculate mean and mode as well here.
yes.
Okay. Do that one as well.
So I'll construct a
Oh,
table to represent.
okay. Then repeat the process described above for each of the following. So once we do this, we can repeat again and again this one. So the six So the six possible selections of five cards denoted there. So earlier, if we have if we did it with six cards, then they ask us to do it again from the by using five cards, four cards, three cards, one cards. Likewise, we can repeat the same process to calculate these x5, x4, x3, x1s as well. එතකොට among those ones, we can again get the means, මේ සම්පූර්ණ process එකම we can calculate it. Now, why they are doing this? What does the single value of x6 represent? Here, do the values of x1, x2, x3, x4, x5 have anything in common? And can you suggest reasons for any of the common features that you observe? What do you think? If we do it repeatedly for the first five, first four, first three, again, first three means the possible three, then
Yeah,
likewise, then what will happen there? Okay, so now anyway, the experiment would be like this, no? So
yeah.
will do the theory part, what they're saying. Now, keep it in your mind. So here for the coded data, okay, for the coded data, what will happen? To code a set of data, we can transform all of its values by addition of a positive or negative constant. We can add a positive constant or we can add a negative constant as well. So the final result of doing this will be the final result of doing this produces a set of coded data. So for example, what we can do, for example, you just think one reason for coding is to make the numbers easier to handle when performing manual calculations. This coding part we normally do it for the category, no, the what we call the categorical variables as well or the numerical variables as well. Because when it comes to categorical variables, I told you no then for the t-shirt size now we have extra small, small, medium.
Yeah.
Likewise, Ithakota, what we normally do, we can code these ones. So for the starting from extra small one, if I coded this extra small one as one, then the small one would be two, medium one would be three, then large one would be four. To convert it into the numerical values also, from that aspect also, what we normally do, we just convert this into the coded ones. Got it? So, method
I didn't understand
that
that
means
part.
just assume we have kind of a data set with the students and their t-shirt sizes කියලා. එතකොට we
Yeah,
have the student name, blah blah blah, and the t-shirt size. So and second student's name and the t-shirt size. Likewise, we have the t-shirt size along with their names. So let's assume we just wanted to analyze it. Can we do the analysis with these categorical variables? Again, මෙහෙමම තියාගෙන we can't, right? Because we
No.
just we can just draw a pie chart and show what are the percentages of extra small sizes. එහෙම කියලා කියනවා ඇරෙන්න. We can't do the analysis, no. So then what we normally do, we have to convert this categorical variable into a numerical variable. We have to represent this extra small, medium, this entire thing as numerics. Numbers වලින් we should represent it. එතකොට මොකද කරන්නේ? We are coding it. We are coding it කියලා කියන්නේ we are defining a rule. If it's extra small නම් number would be 1. If it's small නම් then the number would be 2. If it's medium නම් then the number would be 3. So if it's large num, the number would be 4. If it's extra large num, then the number would be 5. Likewise, we define a rule. Now we don't have these categories anymore, wordings anymore. We have this number set. දැන් අපිට මේ number set එක තියෙනවානේ. Then we can do the numerical analysis more and more. We can find out mean of these ones. We can find out
Hmm.
mode of these ones. ඔක්කොම අපිට කරන්න පුළුවන්. But if we have the general string values, I mean the categorical variables here, there we can draw a pie chart or bar chart. That's only. Bar chart, that's only. That's what we can do. That is why the
Okay.
coding, that is why the coding is a very important thing when. Is it clear?
Okay.
I'll
Yeah,
show
yeah.
some examples. So one reason also it is sometimes easier to work with coded data than with the original data by arranging the mean to be a convenient number such as 0 for example. නිකං හිතන්නකො සමහරක් වෙලාවට 0 and 1 කියලා තියෙනවට okay. So sometimes what will happen if we have bivariable means මේ මොනවද for example, let's assume we have a මොන හරි මොකක් හරි questionnaire එකකට we have an outputs that outputs would be with the yes no questions කියලා. The answer
Yeah.
would be if it's yes nang yes, no nang no. Now what will happen when it comes to yes no questions? මෙතන මේක මෙහෙම තියාගත්තත් we can't do more analysis from this no. Then what we do, we just replace it. If it's yes nang we put 1, if it's no nang we put 0. Then
Okay.
again, what we can do, we convert this categorical variable into a numerical variable by coding. So because of that, we can do more calculations with more analysis, more analytical things. That's what here we do.
Okay.
To find the mean of 101, 103, 104, 109, and 113, for example, we can use the value 1, 3, 4, 9, and 13 as well. Why they have done it? They have coded it. අර මැද තියෙන ඔක්කොගෙම it's zero නේ. Again, and the
Yeah.
last the 113 එතකොට what they have done here, they have neglect the middle value, middle digit. එතකොට middle digit එක මේ මොනවද neglect කළා then they are using 1 3 4 9 30 actually not the middle digit they are neglecting the first one. හැම එකේම first එක එකයිනේ තියෙන්නේ. එතකොට
Yes.
101 103 104 109 113 all these values the first digit is 1. එතකොට ඒකේ මුකුත් uniqueness එකක් නැහැ. Then what they have done, they have coded it into 3, 4, 9, 0, 1, 0, 3, 0, 4, 0, 9, and 30. These are the coded values. See, that's how it is. එතකොට අර ලොකු numbers වෙන්නෙත් නැහැ. Those numbers will program it. So here, what will happen? 1, 3, 4, 9, and 30. It's clear, right?
Yeah. So then the answers that we get, we'll have to change them as well.
Yes. So when we calculate the mean we are representing 6 now. But what would be the actual value? If it's 6 means that is 0, 6. Then we should put that 1 as well. Because I mean
Uh-huh.
So this is not a proper method. Again, proper method කියලා කියන්නේ this is for the coding thing. ඒ කියන්නේ code කරලා එන එක. But these two are, see, the means are different. Here we have 6, here we have 106.
Yes.
So those two values are exactly different. So now what will happen? Our x values are these ones. Then the corresponding coded values are 113, 1, 2, 1, 3, 4, 9, 13. This is, they have find out a numerical relationship in between these ones. That means the x minus 100. ඒ කියන්නේ මේ හැම value එකකින්ම they have subtracted 100. See, එතකොට 101 වලින් 100 අඩු කරාම 100ක් අඩු කරාම 1යි. From this 103, if we subtract this 100, then we'll receive 3. 104 වලින්, if we subtract 100, then again we'll receive 4. Likewise, here we have the coded numbers. එහෙනම්, if we receive this 6 as the numerical value for the mean after coded, what would be the actual value? Actual mean.
We had to add 100 to it.
Yes, we have to add 100 because earlier we converted like x minus 100 by using again how we coded was from the actual numbers, we just subtract 100. එහෙනම්, once we receive this means to get the actual mean of our original data set, to do that, what we have to do, we need to add that 100 here. That's
So
how.
this is like, why do we need to do this? We can straight away add 101.
Yes. For this example, now actually we can do, but if you are handling like large number of data set, ඒ කියන්නේ හිතන්නකෝ නිකන්
Yeah.
ලොකු number set එකක් නම් දැන් මෙතනදී you will feel like මේකේ මුකුත් කරන්න දෙයක් නැහැ නේ, අර ටික add කරලා බෙදුවත් එනවනේ කියලා කියන එක. Yes, that's
Yeah.
true. But here we have only මේ මොනවාද less number of data නේ. ඒ කියන්නේ මෙතන තියෙන
Yes.
6යි. But think if we have like large number of data set, and also if it's a categorical one also, නිකන් එහෙම වගේ complex scenario එකක් හිතුවොත් this method is good because all these numbers are getting smaller නේ. ඒ කියන්නේ අර
Yeah.
this is what we call, ඔයා දන්නව නේද, අර can you remember when we calculate the frequency tables, we had a method, we are selecting a middle value class as අර average එකක් අරගෙන, and then we are calculating the deviations උඩටයි පල්ලෙහාට යන එකක්. Have we
Ah,
done
yeah.
have we done that kind of things? අන්න ඒ වගේම තමයි. So එතනත් lazy අපිට we are deciding a class interval. We are deciding a class interval as there, that is the අර middle value එක තියෙන class එක කියලා we are defining it. එතන ඉඳන් we are calculating the deviations. So deviations are not much higher. සාමාන්‍යයෙන් deviations එනකොට එච්චර අර ලොකු values එන්නේ. It would be -2, -3. උඩට යනවා නම් අඩු වෙනවා නම් ඔහොම යනවා. නැත්තම් පල්ලෙහාට යනවා නම් 1, 2, 3 වගේ add වෙලා යනවා. Then only we just multiply these ones. ඒ වගේ එක එක ඒවා තියෙනවා. but මේක මේ situation එකට ඔයාට නිකන් හිතන එක හරි. It won't much case මේක නම් තනියෙන් කරන්න පුළුවන් කියලා. but if it's a large number of data set නම් sure you should use this method. That's the case. And also තව example එකක් තමයි when we combine data sets, composite ones, anyway we'll be discussing these ones. දැනට නිකම් මේක ඔළුවේ තියාගන්නකෝ.
Okay.
Then we have refer to the following diagram. If we add minus b to the set of x values, they are all translated by minus b, and so is their mean. So the new mean would be x minus b is equals to x bar minus b. That's what we have because so since we are subtracting the value b from each and every number on the data set, then from the mean also what we have to do, once we received x bar, to get the actual value, we need to subtract this b as well. That's how we do the coded or the translation. Hare. So what are those? Is it clear?
Yeah, it is.
Okay. So then what are those what we call the group datas and the ungrouped datas? Here for the ungrouped datas now, we can calculate this x bar like this. When it comes to ungrouped data means actually these ones are raw data set ni etakota we can get the difference in between these values etakota x bar කියලා කියන්නේ x1 minus b and plus x2 minus b and then plus x3 minus b. Likewise, we need to calculate all the differences together and then we should divide it by the number of elements. Make it again we need to add that b as well to get the
Yeah.
overall x bar. එතකොට if it's group data නම් අර frequencies coming to the topic එතකොට කරන්න තියෙන්නේ මේ difference එක relevant frequency එකෙන් multiply කරා and then rather we dividing by the n that means the number of මොනවාද elements we have to divide it from the මොනවාද the total
Total frequency.
frequency and then we need to again add this b as well. So these formulas can be summarized by writing x bar, which means this one. Okay, now for two data sets coded as x minus a and y minus b, we can use the totals sigma x and sigma y to find the mean of the combined set of values of x and y as well. Okay. Let's go. Okay. Can you do, I mean, read and try to do this worked example T point 2.9 as well?
Um,
නැති වෙලාද?
Okay, teacher.
Okay, that is done. Is it clear for you how we gonna calculate these ones?
Yeah,
Okay. 2.10.
I didn't write it.
Okay. So that is for the group data. Group data කියලා කියන්නත් බෑ. Anyway, x minus 3 for these ones nang. Then we have frequency 0, 18, okay, 24 to 32. Okay, calculate the estimate of the mean value.
That's also okay, teacher.
Yes, that's also done. Okay, then can you do only this red color one, the eight question? Yeah, eight question only. Yeah, that's fine. Throughout
Please. Okay.
throughout the career, an athlete has been okay. Anyway, no need. You do those ones at home. That's fine. Take your time and.
Okay.
So here for the E. Now what they are saying, a set of data can be coded by multiplication as well as by addition of a constant. So what will happen here? Suppose the monthly take-home salaries of four teachers. What are those values? That means 3,600, 4,200, 3,7, and also 4,5. These are the all four monthly take-home salaries of teachers. To calculate the mean of these four values, we just add all these four values together and divided by 4. Then we'll receive 4,000 as the mean. Then we have what happens to the mean if all the teachers received a 10% increase but must pay an extra $50 in tax each month. So what do you think what will happen? So that means actually here what happens to the mean if all the teachers received a 10% increase? That means
So
this
we have to re
3,600 now.
yeah,
Then first we need to calculate 3,600. Again, 10% of that 3,600. එතකොට වෙන්නේ මම හිතන්නේ 10% එක කියන්නේ 360යිනේ. Then we need
yes.
to add that 360 for that amount. Then it will become 3,900 and 3,960, right? එතකොට ඒකට 10% increase but must pay an extra 50 as well. එතකොට
Yeah.
හැබැයි වැඩිපුර 50 we need to pay. So then what we can do to find their new take-home salaries, what we have to do? We multiply the current salary by 1.1. 1.1 means because first we need to calculate the 10%, and we need to add it to the total
Add it.
total
Yeah.
value can previous value itself no. එතකොට ඒ
Yes.
කියන්නේ directly what we can do, we can multiply it by 1.1 there and get the new current salary, and then subtract 50, and then out of those values we have to subtract 50. Then the new take home salary is 3,910, 4,570. These are the new salaries. හරිද? එතකොට now for the mean of the new salaries, is we need to add again all these four values and should divide it by 4. That will become 4,350. So the original data, x has been coded by multiplication. See the method. එතකොට මුලින් තිබ්බේ අපිට මේ ටික, then we coded them into these values. 3,910, 4,570, all these values by multiplying it from 1.1 and then subtracting 50. That is the method.
Okay.
Now, if the actual data is x, now how the transformation works here? We should multiply this x by 1.1 and then we need to subtract it by 50. That's the transformation we need to do. Then the mean of the coded data is also 4350, which is equals to, again, what will happen? For the first data set, we got the mean as 4000. 1.1 again should multiply it by 4000 and then we need to subtract this 50, where this x bar is equals to 4000. Again, we'll receive that as 4000. So the data coded as ax minus b has a mean of ax bar minus b as well. The same thing happens. So to
Okay.
find x bar from a total such as this value, we can find the mean of the coded data and then we can undo this minus b and undo this multiplication A. That means these two operations. First, we need to undo the negative B, I mean the subtraction of B, and then we need to undo the multiplication as well. That is what we have done here. එතකොට පස්සේ if we
That's to find the original one, right?
yes, that's what. Reverse case. එතකොට අපිට මේ latest එක තියෙනවා නම් the current එක තියෙනවා නම් to find out the previous one, what we have to do, we have to go it with the reverse case. එතකොට කරන් තියෙන ඉස්සෙල්ලා minus b කරපු එක we need to plus b and then if we have multiplied it by a, then we need to divide by a. We need to do the opposite operations. අර ගැලීම් සටහනක් කියලා කියන්නේ අපි what we call අර in පොඩි කාලේ අපි කරන්නේ we draw these ones and step by steps we'll find out the next theory. එතකොට ඒකෙම පිටිපස්ස
Yeah.
තියෙන්නේ. That's what we have to do. Is it clear up to this point?
Yes.
Okay. Shall we work on this worked example 2.11?
Okay. Okay, teacher.
Okay, that also done. Then we need to do both 11 and 12 done. No? Okay,
Yeah.
then, okay. So you can try these ones at home and we'll move to the median. Okay, so if I move to the median here, now what will happen for the median? Now what will happen for the median? That is, median means anyway the middle value. Median means anyway the middle value. So you will recall that the median splits a set of data into two parts. So what will happen here with an equal number of values in part A? part A bottom half, and also the next part is the top half. So we have like two parts. In a set of n ordered values, the median is at the value halfway between we can first one and the nth one. So anyway, if we have like 10 term now the 10 number of elements now, then the middle value is in between fifth and sixth. And if we have like 11 elements, then ideally the sixth value is if we have like 11 now, then the sixth value is the median value. That's what we normally do. Now
Yeah.
here, consider a DIY store that opens for 12 hours on Monday and for 15 hours on Saturday as well. So the numbers of customers served during each hour on Monday and on Saturday last week are shown in the following back-to-back stem and leaf diagram. So now we already did about the stem and leaf diagram. What they are saying here, to find the median number of customers served on each of these days, so we need to find their positions in the ordered rows of the back to back stem and leaf diagrams. So what will happen here? For Saturdays, there are 15 elements. N is equals to 15. 15 values arranged in ascending order. That means from the smallest to largest, and then ascending order from top to bottom and from left to right as well. So the median is what will happen? N plus 1 over 2th position එකේ තියෙන value එක තමයි we considered it as the median. That means 15 plus 1, 16. 16 divided by 2, that is 8. The 8 value. This is the index actually, the position. Now, in the first row, we have the first to fourth values. The first row we have first to fourth values. What is the actually eighth one? 1, 2, 3, 4, 5, 6, 7, 8. 8, right? 8 that means the 38. 38 is the middle value or the median of the Saturday values. Is it clear?
Yes.
Okay. If we have like, let's assume we have n is equals to 12, that means an even number of elements scalar. If we have even number of elements, again we have to do the same thing. එතකොට n plus 1 divided by 2th one. That means 12 plus 1 divided by 2th one. That means 6.5th one. හැබැයි there's no any 6.5th case එකක් නේ. 6.5 කියලා position එකක් index එකක් there we don't have. එහෙනම් what we
Yeah.
have to do? We have to get the sixth value and the seventh value together and divide it by 2. 6වෙනි value එකයි 7වෙනි value එකයි දෙක එකට අරගෙන add කළා we should divide it by 2. That means 28 plus 30 should divided by these 2. Then you will receive the median value as 29. That is the
Okay.
second method. Second method means if we have even number of elements, we go with the second option. If we have the odd number of elements, we can go with the first option. That is the two different methods. Anyway, the criteria is same. So it's clear, right? Is it?
Yeah.
Okay. So when data appear in an ordered frequency table of individual values, so we can use cumulative frequencies to investigate the positions of the values, knowing that the median is at the n plus 1 over 2th value. That's what they also mentioned here. Okay, that is done. Can you work on this worked example 2.13? The 13.
Okay. Okay, teacher.
Okay, that is done. It's also clear, right? Then
Yeah.
we the estimating the medians. So what will happen here for the estimating the medians? Okay, estimating the medians. Okay, then we have the frequencies. Okay. So here for the estimating the medians in large data sets and in sets of continuous data, values are grouped and the actual values cannot be seen as well. Actual values cannot be seen. So this means that we cannot find the exact value of the median, but we can estimate it. That means the method we use to estimate the median for this type of data is by reading its value from a cumulative frequency graph. So we estimate the median to be the value whose cumulative frequency is equal to half of the total frequency. What does that mean? So here we are going to estimate the median value. Estimate means that's not the actual value. We are going to නිමානය කරනවා අනුමාන කරනවා වගේ දෙයක් තමයි what
Yeah,
we
get a
call
rough value.
yes, getting a rough value. So here in large data sets and in sets of continuous data, those values are grouped and the actual values cannot be seen. Then what will happen? This means that we cannot find the exact value of the median, but we can estimate it. By looking at a graph also, සමහරක් වෙලාවට හරිම exact value එක we can't read it, but we can have a kind of අර ළඟින් යන estimated value එකක් we can read it. So the method we use to estimate the median for this type of data is by reading its value from a cumulative frequency graph. Then this cumulative frequency graph means we estimate the median to be the value whose cumulative frequency is equal to half of the total frequency. Then that means consider the, so if we consider the masses of 300 museum artifacts, then the half of it means actually 150. එහෙනම් මේකේ 150 වෙන තැන තියෙන value එක තමයි we need to read it. So here we drew the cumulative frequencies. එතකොට මෙතන we have 150. Then what will happen? We have to read the respected value, I mean that value which is available for 150. So 150 වෙන්නේ somewhere around here. එතකොට I can roughly read it as 2.6 වගේ. නිකන් if I estimate it and read it, then the value would be 2.6 වගේ something. Right. So the set of data has a total of n. So this n value is equals to 300 values and an estimate for the median is the mass of the n over 2. That means 150 value. So then, as I told you, it would be approximately, if we read it from the graph itself, then it would be 2.6 kilos. That's what we have.
Okay.
Okay. Then we have the did you know? Okay. Did you know one? It's kind of our concept representing many different measures. Okay, that is it. Then I'll move to the next theory, what we call the choosing an appropriate average. So for the previous one, now, when it comes to average, as I already told you, we have three types of values. One is mode, other one is mean, other one is median. According to the context and the scenario which they have given, according to the problem, we should choose what would be the best average. Again, what would be the best value to represent this average කියලා කියන එක. Then
Okay.
happen, selecting the most appropriate average to represent the values in a set of data is a matter for discussion in most situations. So just as it may be possible to choose an average that represents the data well, so it is often possible to choose an average that badly misrepresents the data. Then what will happen? So the purpose of motives behind choosing an average value must also be considered as part of the equation. That means now what they have given, consider a student whose marks out of 20 in tests are, in 10 tests are, what are these marks? These are the marks for 10 tests. So the three averages for this set of data are, what are the averages? If we calculate the mode means the highest frequency value, that is 17. Mean means add those ones and divided by the number of elements, that is 9.8. For the median value now, it's already ordered. එතකොට 20 කියලා කියන්නේ 10 means actually කියන්නේ 20 කියලා කියන්නේ 20 plus 1 divided by 2 නේ, that means 21 divided by 2, that means 10.5. එතකොට you have to add the 10th value and the 11th value together and divided it by 2. That's how we normally calculate it. These are
Okay.
all these methods for that. If the student wishes to impress their friends or parents, then they are most likely to use the mode as the average because it is the highest of the three. Then using either the mean or the median would suggest that on average, the student scored fewer than half marks on the test. We should be able to give this kind of a representation. So that representation come in comparing mean and the median value, because the median value is 9.5. එතකොට half එකකට වඩා අඩුවෙන්, ඒ කියන්නේ හරියට මේ සෙට් වෙලා තියෙන 9.5 වලින් and the mean value is 9.8. If we compare those two, we can interpret this result, this comparison, that is, if the student wishes to impress their friends or parents, they are most likely to use the mode as the average because it is the highest of the three. Then using either the mean or median, 9.8 and 9.5 would suggest that on average, the student scored fewer than half marks on these tests as well. ඇත්තටම කියනවා නම් භාගයටත් වඩා අඩුවෙන් තමයි marks අරන් තියෙන්නේ. That's the මොකද මෙතන average එක එන්නේ 9.8. I mean the mean value is 9.8. හැබැයි median value එක 9.5. ඒ කියන්නේ භාගයකට 9.8 වලටත් වඩා අඩුයි. mean එකට average mean එකටත් වඩා අඩුයි. That's what they have mentioned here. Is it clear?
Yeah.
Okay. So some of the features of the measures of central tendency are given in the following table. Here we have the advantages and the disadvantages. Mode, mean and median values are there, and we have the comparison. Unlike to be affected by extreme values can outliers. So then useful to manufacturers that need to know the most popular styles and the sizes, can be used for all sets of qualitative data. All these ones are advantages, and here they have given the disadvantages of these. Again, may values අපි use කරද්දී what are the disadvantages we will found. That is kind of a quick comparison in between those two. So as an example of the effect of an extreme value, consider the data set 40, 40, 70, 100, 130, and 250. If we increase the largest value from 250 to 880, then the mode and median are unchanged. That is 40 and 85. But the mean increased by 100% from 105 to 210. What does that happen? Okay. As an example of the effect of an extreme value, consider the data set. Now the original data set is this one. No? If we increase the largest value from 250 to 880, හිතන්නකො මෙතන තියෙන 250 කියලා කියන එකට that would be increased up until 880. Then the new
Yeah.
set would be 40, 40, 70, 100, 130, and 880. If we calculate the mean, what will happen? For the previous mean, original data set, it was like ඔයාට calculate කරොත් 105 වගේ. By using this, by having this 880, the highest value would be 210. See, then it
Yeah.
has been completely doubled up. 100% සම්පූර්ණයෙන් increase වෙලා තමයි තියෙන්නේ. So although the median is usually unaffected by extreme values, so this is not always the case as the Liber scanned shows as well. That so anyway in statistics we need to have a clear idea to interpret all these our results. ඒ interpretation එකට තමයි වැඩිපුරම marks හම්බ වෙන්නේ. So we should
Okay.
theory part එක හොඳටම thorough වෙන්න ඕනේ. So consider the number of days taken by a courier company to deliver 100 packages as given in the following table and represented in the bar chart as well. Here 1, 2, 3, 4, 5, 6. These are the number of days. එතකොට එක ඇවිල්ලා තියෙනවා 10ක්, දෙක ඇවිල්ලා තියෙනවා 40ක්. Likewise up until 6 ඒවා ඇවිල්ලා තියෙනවා 3ක්. Then a curve has been, if we draw the frequency table and the frequency graph actually, මොනවාද ඒකට කියන්නේ අපි කියනවානේ
Histogram.
Yes, histograms. So a curve has been drawn over the bars to show the shape of the data. Then the mode is 2 days. Anyway, the mode will be 2 days. Padipurama තියෙන the highest frequency value it would be mode. Mode is 2 days and the median is between the 50th and the 51st. දෙකේ median එක ගත්තොත් that means the value which is available in the midpoint මැද තියෙන එක middle, so it will be 2.5 days. Then to calculate the mean නම් අර විදිහටම මේ ටික ඔක්කොම multiply කරලා and then we need to divide it by the total number of packages that would be 100. එතකොට you will receive 2.79 as the mean of this actually mean. That means the number
Yeah.
of days, 2.79. So the mean is the largest. Among all these three values, mean, mode, and the median, the mean is the largest average and is to the side of the curve's longer tail. Then the mode is the smallest average and is to the side of the curve's shorter tail, and the median is between the mode and the mean. ඒ කියන්නේ මේක මෙහෙම ගත්තොත් මැද තියෙනවා හරියටම the median is in between mode. එතකොට මෙතන තියෙන්නේ median එක. Then the mode will be in the left hand side. මෙතන තියෙනවා mode එක and මේ පැත්තේ තියෙනවා mean එක. That's how here this one works. So
Yeah.
a set of data that is not symmetrical. Symmetrical means මේ තුනම එක ළඟ තියෙන්න ඕනේ. Mean එකයි, mode එකයි, median එකයි, all these three values should equal. හැබැයි if it's not, we say it as skewed. Skewed වෙන එකේ we have two methods. One is this way skewed. ඒ කියන්නේ නිකන් left hand side එකට tail එක ඇවිල්ලා. Okay? Then the other way is the whatever they have drawn. ඒ කියන්නේ මෙහෙම ඇවිල්ලා the tail goes somewhere around here. මේ පැත්තට tail එක එනවා for the positive side එකට tail එක එන එකයි. මේ පැත්තට එනවා negative side එකට tail එක එන එකයි. අනිත් the symmetric actually all these three values are equal. එතකොට නිකන් it's kind of a bell shaped one. හරියටම bell එකක හැඩයකට තියෙනවා mean එකයි median එකයි mode එකයි තුනම එක තැන තියෙනකොට. හරිද?
Okay.
Now, for these two, we called a special name, that is, these two are skewed here. When it comes to skewed, a set of data which is not symmetrically said to be skewed when the curve's longer tail is to the side of the larger values, අර දිගට තියෙන වලිගේ තියෙන්නේ positive side එකට නම්, as in the previous bar chart, then we called it as positively skewed. මොකද මෙතන skewed වෙලා තියෙන්නේ positive side එකට. Okay.
Okay.
හැබැයි for this one මෙතන skewed වෙලා තියෙන්නේ that is for the negative side. So for these kind of data sets or graphs we called it as positively skewed. For these type of ones we called it as negatively skewed. For the if those three values are equal, mean, median and mode, then we call them as what? The symmetric data set. ඒක තමයි shape එකෙන් How we gonna comment those three? When the curve's longer tail is to the side of the larger values, as in the previous bar chart, so the data are said to be positively skewed. When the longer tail is to the side of the smaller values for the left-hand side, now we would say it as negatively skewed. Generally, make a mathematically if we represent it, මෙන්න මෙහෙමයි වෙන්නේ. Positively skewed means මෙහෙමනේ. So then, mod, here we have the, okay, this, there, okay, so this one. Then the highest frequency value, we have the mode, no? Mode, somewhere around here we have median. Then somewhere around here we have the mean. If it's positively skewed, then mode එකට වඩා median එක ලොකුයි, median එකට වඩා mean එක ලොකුයි. And if it's negatively skewed, that means the left side arm will be like skewed. ඒ කියන්නේ දිගට tail එකක් විදිහට එනේ. එතකොට then what will happen? Mode comes here. එතකොට here we have mode. මෙතන තියෙනවා median. Then මේ වගේ තැනක මෙතන තියෙනවා mean එක. So then that means mean එකට වඩා median එක ලොකුයි, median එකට වඩා mode එක ලොකුයි නම් if a data set belongs to this kind of a relationship, then that data set we can say it as negatively skewed. So for the first one, it's positively skewed. For the second one, it's negatively skewed. If these two methods, I mean, if all these three values are equal, it's a bell-shaped one, which we call the symmetric. එතකොට හරියටම මේ තුනම එකම තැන තමයි තියෙන්නේ. මෝඩ් එකයි, මීඩියන් එකයි, මොනවාද මීන් එකයි තුනම එක තැන තියෙන්නේ. Those are the three changes. Three types of data sets, skewed ones.
Okay.
Yani if they ask you to comment it with the shape of the curve, එහෙම වුණොත් you should talk about the skewedness. Correct.
Okay.
Then, okay. Okay, that's it. Okay. So, shall we do this? Sehinang, you can, I think for the questions also, you can take your time and tried it, right? එතකොට so
Yeah.
you can like spend more time on the questions. එතකොට මොන හරි අවුලක් આવොත් මගෙන් අහන්න. Then we are done with the chapter 2 as well. So chapter 2 also done. You can complete all the exercises, whatever we have for the chapter 2. And then you can do the review exercise as well. I mean the chapter review one, final one, chapter review exercise 2 as well.
Okay.
Then the chapter 2 also done. Yes, then we have to start with the measures of variations. That one we'll do next day. That's fine. Okay?
Okay, teacher.
Okay, then that's all for today. Then thank you so much.
Okay, thank you, teacher. Good night.
Bye.
Bye.
Bye.